Okay, Honors Chem, I am sorry. I don't know what happened. I was telling you about how sodium will ditch its 3 s electrons right there and go to neon's noble gas configuration to get a noble gas configuration. And by ditching that outermost electron, it acquires a +1 charge. Okay, so how does the size of the positive ion compare with an atom? So let's look at sodium as it is, and we're going to draw the Bohr model. So I have my 1s electrons. I have my 2s electrons. And I have my 2p electrons. And then I have my 3s electron. Okay? So if I want to get back to a noble gas configuration, what I need to do is I need to get rid of this electron. So if I look at sodium as a positive ion, I will have my nucleus right here. I will have my 1s electrons and my 2p and 2s electrons. And this gives me, let's look at these together. So this gives me, on normal sodium, I have 11 protons, I have 11 electrons, and on this sodium, that's an ion, I have 11 protons, but I only have 10 electrons. Okay, I've gotten rid of this whole outer shell to go down to the noble gas configuration of neon. So not only do I miss this whole shell to make myself smaller, I also have more protons compared to electrons to pull those electrons in even farther. So these electrons are going to be pushed into the nucleus a little bit closer because I have that extra proton pulling in compared to neon. Okay? So the size of a positive ion compared to the atom from which it is made, the ion is smaller than the atom. Okay, and there's 2 reasons why that is. First, we got rid of the outer valence shell. So usually the outer valence shell is gone. So we shrink that. And the other reason why this is so is we now have a greater proton to electron ratio to pull the electrons in even tighter. Okay? How can we make a negative ion? So if I can make a positive ion by getting rid of electrons, can I make a negative ion by adding electrons? Yeah, I make a negative ion by adding electrons. Oh boy, what is it doing? So I make a negative ion by adding electrons. So let's think about this. Let's look at oxygen. If I look at oxygen, I have 1s2, 2s, 1, 2, 3, 4, 5, What is my Hudley camera doing now? Oh boy. I've got 6 valence electrons. But in order to have a noble gas configuration, I need to either get rid of these 6 electrons, or I can grab 2 more electrons and get to the noble gas configuration of neon. So that's what oxygen does. It's a lot easier to grab 2 extra electrons than to get rid of 6. So oxygen comes with a -2 charge. So if I do that, I've got my oxygen with my 1s2. Then I have all 8 of my valence electrons. So that gives me the same configuration as neon, but now I have 2 extra electrons. So I have more electrons than I have protons. That means these electrons get pushed out because I have more of a negative charge than I have of the protons. So my negative ions are going to be larger than the atom from which it comes, and my positive ions are going to be smaller than from what they come from. So negative ions are larger than their atoms. Okay, so profundity. Positive ions are always smaller. Positive atoms are always smaller than the atom from which they come, and negative ions are always larger than the atom from which they come. Okay, we will talk about this more next time. Here's a periodic table with the trend on atoms. Okay, notice that when you move down a group, ionic radius generally gets larger. And when you move across a period, positive ions get smaller. And negative ions also get smaller. Okay, that's enough for now. We'll talk to you later. Bye.